topics that you are unable to understand. Tell me your doubts. Please let me know your doubts.
Sir, I don't have any doubts.
Oh, I thought you have doubts. So please wait for a few minutes. Other students are joining. Then we are gonna start a new chapter. Okay, chemical kinetics.
Okay, sir.
Is there any upcoming exams or unit test in your school?
Sir, this month I don't have anything.
Okay. Okay, let's just start a new chapter. Let me share that new slide that is basically chemical kinetics. Chemical kinetics. So basically, here what we are going to learn is basically, as you know, that this is kinetics. So kinetics, that means in motion. So basically here we are going to learn the mechanism and also the rate of reaction. So we can write a point about this chapter, the branch of physical chemistry. Then write with me, the branch of physical chemistry which deals with the study of which deals with the study of rate of chemical reaction, rate of chemical reaction, and the mechanism by which the reaction proceeds. What is the mechanism behind it? Is called chemical kinetics. Is called chemical kinetics. So it's very easy to understand. Basically, what is chemical kinetics? So here we are going to deal with the rate of reaction and also the mechanism to proceed the reaction that comes under chemical kinetics. So first of all, we are going to start the rate of reaction. We are going to start the rate of reaction. Please do let me know if you are done with the above definition. Then we are going
Okay,
to
sir.
start.
Done, sir.
Okay. Now see what is rate of reaction. So basically it's very easy to understand what is the rate of reaction. Basically it is change in concentration of reactant and product per unit time. That is called rate of reaction. So here I am going to write. It is defined as, write with me, it is defined as changing concentration, or if the reactant or product is in gaseous state, so we will take pressure for that. We will take pressure for that, either change in concentration or pressure of reactant of reactants and products per unit time. Products per unit time. So this is basically called reaction. So we need to see only the change in reactant or product. Either it is expressed in concentration or pressure depending upon the reactant and product per unit time. That is called rate of reaction. So basically, if I am going to write only the rate will be equal to change in concentration of reactants or products per unit time. Per unit time, that means time taken. Time taken. And you know what? There will be either positive sign or negative sign. For positive sign, it is for basically product, and for negative is for reactant. Why it is so? See, What does change means? Change means basically change means final minus initial. Final minus initial. If we are going to see, if we are going to calculate change in concentration of reactant, that means basically final reactant minus initial reactant. And as you know that if there is reaction, A is converting into B. So initially at T equals to 0, that means before the start of the reaction, just suppose A has a concentration A, small, and it will have a concentration G. But after some time, A is converting into B. A is A minus X. It becomes A minus X. That means some of the concentration of A is going to convert into B, and here it forms X. So for reactant, this is the initial concentration, this is the final concentration, and as you know that initial concentration will be larger in magnitude than final concentration. That's why negative sign is with reactant, but in case of product, this is the initial and this is the final. Final will be always larger than initial. That's why final minus initial will be positive sign. So basically this positive sign shows that product concentration of product increasing, and negative sign shows that concentration of reactant decreasing. Is that clear?
Yes, sir.
So we can also write rate is equal to plus minus delta C upon delta T. And this C is stand for concentration. And positive is for product because concentration increases if you are going to calculate the change, final minus initial. And in negative, for negative, you can see decreasing concentration of reagent. So please do that. Please do let me know when you are done with this.
Done, sir.
Very good. Can you calculate the unit of rate? Unit of rate. Unit of rate. Can you calculate the unit of rate? Yes or no?
I don't think so, sir.
See, do you know the unit of concentration? This concentration in a square bracket represents molarity. Do you know the unit of molarity? Yes or no? Just answer me clearly.
Mole.
Only more. Do you know the formula of molarity that we have studied in chapter 2 solution? Molarity, formula for molarity. It is basically number of moles of solute upon volume of solution in liter. So the unit of molarity will be moles per liter. Yes or no?
Yes, sir.
So you can see this is concentration. So I'm going to put the value moles per liter, and you know the unit of time will be second. So basically the unit of rate, if it is expressed in concentration, it will be mole per liter per second. Okay. And if unit is if the term basically if the reactant or product is in gaseous state, I told you that we are going to use pressure instead of concentration. So if we are going to use change in pressure here, so the unit will be pressure, that means unit of pressure, you know, atm per second. It either it will be atm per second or bar per second according to the question. Are you getting my point? If gaseous, then rate will be basically change in pressure upon time, change in pressure upon time taken. So you can see the unit comes from the formula, either it will be atm per second or either it will be bar per second. Are you getting my point, Rim?
Yes, sir.
So please do write it. Then we are going to do a graph and then we will move on. Let me know when you are done with this.
Done, sir.
Okay. Now I am going to show you a graph. We are going to do graph between concentration versus time. There will be three graphs. Basically, these two graphs will be combined in a single graph. That is our third graph. That is our third graph. So I will show you concentration versus time. First of all, if I'm going to draw for a reactant, you know, if you are going to do a reaction, you have some concentration of reactant, right? You will have some concentration of reactant, and if the reaction will start, the concentration will be decreasing. Yes or no?
Yes, sir.
And if you are going to plot a graph for product, the concentration initially for product will be zero, and after reaction, the product concentration of product will be increasing. The concentration of product will be increasing like this. So if I'm going to plot both graph, reactant and this is for reactant and this is for product. If I'm going to plot this both graph in a single graph, that will be, this is for reactant and basically this will be for product, right?
Yes, sir.
This graph is all about concept. So if you will not be able to understand, please let me know. As you know that reactant will always have some concentration that is going to react. That's why reactant is started from here, and after initiating the reaction, it will be decreasing. And as you know that the product will be initially zero, and after starting the reaction, initiating the reaction, there will be increasing in increasing order of product. So both graphs will be like this. Please do that. Let me know when you are done with this.
Done, sir.
Come to this rate, which is very easy to understand. If you have a reaction like A is converting into B, so if I'm going to write, as you know that this reactant will decrease because the reaction proceed and reactant will be converted into product. So can I say disappearance of A, because after some time the product basically the concentration of reactant decreases, and if the reaction will go for 100%, reactant will be all the reactant will be converted into product. So here we use rate of disappearance, this term disappearance for reactant, rate of disappearance for reactant, and it will be basically minus delta A upon delta. And you know why does why we use negative? Negative only shows decreasing, because the concentration of reactant decreasing, or we can write basically final minus initial concentration of A2 A1 upon T2 minus T1. Are you getting my point?
Yes, sir.
And if we are going to write for B, you can see initially it was 0, but there will be increment in its concentration after 0. So we use appearance, rate of appearance, we write appearance for product. So it will be positive delta B upon delta T. And we can write also B2 minus B1 upon T2 minus T1. Are you getting my point?
Yes, sir.
Now focus here, it's very easy to understand. Rate is of two types. If you want to divide it, it will be of average rate or instantaneous rate. Instantaneous rate. You have studied velocity like instantaneous velocity and average velocity. Average velocity is like over a period of time, and instantaneous velocity at a time. So basically, this is like that. Average rate of appearance or disappearance, or average rate, is over a period of time like 1 second to 10 second, and instantaneous rate is like on 10 second what was the rate. Are you getting my point? So basically this instantaneous rate is denoted with D. Like if I'm going to denote it by delta, that means uh, we are dealing with average rate, average rate. But if I want to write the instantaneous rate, I will write d of A upon d. I will write d of B upon d. Are you getting my point?
Yes, sir.
So please write it. Ayman, you are late half an hour. Why it is
Yes.
so?
Sorry, sir.
Yeah, that's okay. But my question was why you were late.
I was sleeping, sir.
Oh, at this time, very good. Okay, just hold on a minute. I will slide it up. We just started a new chapter, that is chemical kinetics, and then I'll give you an overview, and then you can write or take a screenshot, whatever you prefer.
Okay.
Ring, let me know when you are done with this. Rain.
I'm still writing, sir.
Okay, please let me know when you are done with this.
Done, sir.
Here, I mean, see, we just started chemical kinetics, and what is chemical kinetics? Basically, it is a branch of physical chemistry in which we are going to study the rate of reaction and the mechanism within which reaction proceeds. This all mechanism and rate of chemical reaction comes under chemical kinetics. Okay, I mean,
Okay, sir.
so we just started the rate of reaction. And what is rate of reaction? So basically, change in concentration of reactant and product per unit time, that is called rate of reaction. I used concentration, but if the reactant or product will be in gaseous state, so we use pressure. We will use pressure. So it can also be written as rate is equal to change in pressure of reactant or product upon time, basically per unit time. So as you know that what is change? Change, that means basically generally final minus initial. So please take a screenshot, then I will show you the equation. Done.
Yes, sir. Done.
Okay. So see, I just wrote rate. Rate is equal to change in concentration of reactant or product upon time taken to change in reactant or product. So there will be positive or negative sign. There will be positive or negative sign. Or as you know that positive is for product, because initially product will be zero and finally it will be something like the value of something. So final will have something. So that minus zero, it will be positive. So the change in concentration or pressure of product will be positive, and the change in concentration or pressure of reactant will be negative, because you know that initially reactant you will have something, but after some time it will be decreasing. So the final value will be lesser than the initial, and final minus initial will be negative. That's why we use negative and positive. This does not mean the concentration is in negative or positive. This positive for product shows that it is increasing, and this negative for reactant shows that it is decreasing. Is that clear?
Yes, sir. Okay.
So this is it. Please do write it or take a screenshot.
Yes, sir. Took a screenshot.
Very good. Now we are going for basically unit of rate. If you know the formula, you can write the unit easily. We know change in concentration. So what is the unit of concentration? Concentration here, that means molarity, and you have studied molarity, that is number of moles of solute upon volume of solution. So molarity has a unit mole per liter, and in denominator you can see time taken second. So unit will be mole per liter per second. If if the reactant or product will be defined in terms of concentration, but if it is defined in terms of pressure, so in numerator we will get change in pressure. And what is the unit of pressure? Either it is atm or bar, whatever is the question. Atm per second, it can be the uh, unit of rate can also be atm per second or bar per second. Are you getting my point?
Yes, sir.
So please take the screenshot again.
Okay, sir. Done.
Very good. Now come to this point of the graph. Can you understand the graph by looking at it? This is for reactant, this is for product, and then I just mixed it up in a single graph for reactant and product. You have seen this graph in 11th class, 11th also. I think so. What do you think? Please do let me know if you don't understand the term.
This is therefore reactant as time goes on, the concentration becomes less, and the opposite for product.
Yes, as you know that we are going to react something that is reactant. You will have some quantity of reactant, concentration of reactant. And when you are going to initiate the reaction, the reactant will decrease with time. And you know that the product, for product, as you know that initially the product will be zero, and then after some time it will be increased. Okay, and then we just mix it up in a single cup. Madiha, please do a speaker. I need to talk to you. Madiha,
Yes, sir.
Aman, are you done with this?
Almost, sir.
Okay. Here I will just slide it up. Just take a screenshot. I just
Okay, sir.
Yes, sir, done.
I took, sir.
generally see rate of disappearance we use for reactant because it has started decreasing, and the rate of appearance we use this term for product because initially the product is zero and then start increasing. So rate of disappearance will be for this reaction, it will be A2 minus A1 upon T2 minus T1. At time T2 it will have A2 and A1, and as you know that reactant decreases, so the value will be in negative, and this negative only shows you that this is decreasing. And for appearance, you know that the product started from zero and it started increasing, so it will have positive sign that indicates its increase. So this delta we use is basically for average rate. When we are going to use D, that is instantaneous rate. At the place of delta, we can use D for instantaneous rate. So please write it. Let me know when you're done with this. Aman, are you done with this?
No, sir.
Okay. Are you done with this?
Yes, sir.
Madhya, please take a screenshot of this.
Yes, rate of it.
Please take a screenshot of this. Did you take a screenshot of this?
Yes, rate of it.
Done. So moving to the next point, I'm going to give you an equation and write the rate of appearance and disappearance. So we use disappearance for reactant and we use appearance for product, CC plus T. So here you are going to write for this rate of disappearance will be for 2 because there are 2 reactants. Rate of disappearance of A will be equal to minus delta A upon delta T. Can you write the rest of it? Ayman, Prem, Madhya.
I'll try, sir.
Okay, please do it. I'm waiting. Aman, what happened?
No, sir, I can't do it.
It's very easy. For reactant, this is the another reactant. We will use disappearance. When you are unable to solve it, just let me know. Don't waste your time. So it will be minus delta B upon delta T. Then come to the product. Product is in appearance, so rate of appearance of C, because we have two products, so it will be plus delta C upon delta T. Delta T. The rate of appearance of D will be equal to plus delta D upon delta T. Are you getting my point?
So is that it? Is that the answer?
Yes,
Okay, sir.
it's very easy, right?
Yes, sir.
Are you done with this?
Yes, sir.
Okay. If I'm going to give you H2 plus I2, can you write the rate of appearance and disappearance?
Yes, sir.
It's very easy, right, Madhiha and Dream?
Yes, sir.
Yes, sir.
Please do write it. Rate of disappearance of H2, then rate of disappearance of I2, then rate of appearance. Appearance we use for product. So it will be minus delta H2 upon delta T. It will be minus delta I2 upon delta T. It will be plus delta HI upon delta T, right?
Yes, sir.
Now we are going to write the rate of reaction in terms of the stoichiometric coefficient. Can I change the slide?
Yeah, sir.
I'm in. Aman, are you done with this?
I'm doing it, sir.
Okay, okay. Please take your time, let me know.
Yes, sir. Done.
Okay. So moving to the next topic, that is rate of reaction in terms of stoichiometric coefficient of chemical reaction. How we are going to write the rate of reaction in the form of a stoichiometric coefficient? So basically, if you have AA plus BB reaction, and you are not going to write a rate of appearance and disappearance, but really you are going to write the rate of reaction. So the rate of reaction, it's very easy. Rate of reaction will be equal to whatever is the stoichiometric coefficient, it will be in denominator. Whatever will be a stoichiometric coefficient, it will be in denominator. And since it is a reactant, so it will decrease. That's why we put minus sign. Is that clear? Whatever is the stoichiometric coefficient will come in denominator, and there will be negative sign because it is reactant, it will decrease. And then again delta A upon delta T. You can put this delta inside this square bracket. Delta A upon delta. That will be equal to C for B. B, since it is reactant, I'm going to put negative first, and then see what is the stoichiometric coefficient. It will come in denominator, and then delta B upon delta T. Again, equal to. This is product, so I'm going to put positive, and whatever is the stoichiometric coefficient, it will come in denominator, and again delta C upon delta T. Again, it will be equal to positive because it is a product, and since D is the stoichiometric coefficient, it will come in denominator, and again delta D upon delta T. Is that clear, everyone? And this rate of reaction in terms of stoichiometric coefficient are equal. That's why I wrote.
Sir, won't it be A plus B is equal to C equal to D?
What you just said?
So here you wrote the rate of reactions as -1 by A and delta by delta T is equal to.
No, this is all overall rate of reaction. You can write in a separate way, like rate of reaction. This they will be equal. That's why I wrote in a single line. They are equal. So rate of reaction will be like this. This will be equal to this. This will be equal to this. This will be equal to this.
Okay, sir.
Please let me know when you are done with this. Are you done with this?
Done, sir.
Simon, Madhya.
Yes, sir, done.
Yes, sir, done.
Okay. So here are a question. Here is some question about this. Express the rate of reaction for following Yeah, rate of reaction, not rate of appearance and disappearance. I'm talking about 2SO2 plus O3 will give 2SO3. B is 2 and 2, 5 will give you 4N1 plus O2. C is half H plus half I2. That will give you a. Please do this 3 questions. Just let me know when you are done. Are you done with this?
So just doing the last question.
Okay. match your answer with mine. Rate of reaction will be equal to minus 1 by 2 delta SO upon delta T will be equal to minus 1 by 1 you can write delta O3 upon delta will be equal to positive 1 by 2 delta SO3 upon delta T. And here the rate of reaction will be equal to minus 1 by 2 delta N2O5 upon delta T, that will be equal to plus 1 by 4 delta NO2 upon delta T, that will be equal to plus delta O2. 1 by 1 you can write or not, whatever you wish. And if you are going for rate of reaction, you can see here that minus 1 upon 1 by 2, it will be 2. Yes or no? Please focus here. If you are going to write 1 upon 1 by 1 upon 1 by 2, so 2 will be in numerator, and again negative 2 delta I2 upon delta T, and again plus delta Hi upon delta T. Is this correct? The C1 of everyone, Karim? Madina?
Yes, sir.
Can I change the slide?
I'm
Amen?
writing, sir.
Okay, please do write it. Let me know. Or is better. No problem. Let me know when you are done with this.
Done, sir.
Aman, are you done with this?
Yes, sir.
No. Now the last relation I'm going to give you, last question of this, is basically D1. D is basically your BrO3 minus. Please do this. And then 5Br minus, and then 6H plus will give you 3Br2 plus 3H2. Dear, let me know when you are done with this. Very good. I'm going to write the answer. Rate of reaction will be equal to, here is no stoichiometric coefficient, one stoichiometric coefficient. So I can write this delta BRO3 minus upon delta T will be equal to, it is reactant, so 1 by 5 because its stoichiometric coefficient is 5, and then delta Br minus upon delta T will be equal to, since it is also a reactant and its stoichiometric coefficient is 6, so it will be like this delta H plus upon delta T, that will be equal to, move to the product, so it will be positive, and stoichiometric coefficient is 3, so plus 3 delta Br2 upon delta T, that will be equal to plus 1 by 3 delta H2O upon delta T. Have you done correctly, Raymond? Ayman?
Yes, sir.
Okay. Can I change the slide?
Yes, sir.
Okay. Rim?
Yes, sir.
Okay. Now see, we are going to learn about a law that is known as rate law. First, I'm going to write it. Write with me, then I will explain. The experimental expression of rate in terms of concentration of reactant is known as rate law. So basically, there is an expression that will be calculated experimentally. That experimental expression is known as rate law, and it is in terms of reactant. Just suppose if we have a reaction AA plus BB, that is giving product anything, CC plus DD or anything, the in terms of rate is directly proportional to reactant A into reactant B, and there will be power that will be calculated experimentally. And to remove this proportionality sign, we will use a constant that is known as rate constant. That is known as rate constant. This is rate constant. And this X and Y is basically experimentally determined. Experimentally determined. This X and Y experimentally determined, and X and Y may or may not be equal, may or may not be equal to A or B respectively. It can be equal to its stoichiometric coefficient, or it cannot be equal to its stoichiometric coefficient. That depends on its experiment. Okay, so this power is determined experimentally. Please do write it. Are you done with this?
No, sir.
Okay, please do it. Let me know when you are done with this. Very good, Nadia. Rain. Aman, are you done with this?
Yes, sir.
Okay. So it's very easy. What is rate law? Rate law is expressed in terms of reactant and it is experimental expression. And we know that rate is directly proportional to the product of the concentration of reactant to the power something that will be experimentally determined. And this power can be or may not be equal to its stoichiometric coefficient. Now, related to this, a topic is there, order of reaction. Order of reaction. Then you will get it. Write its definition. What is order of reaction? So basically, order of reaction is the sum of power of concentration of reactant in rate law expression. In rate law expression is known as order of reaction. Order of reaction. So basically, if there is any rate law expression and this order of reaction is denoted with N. If you have a reaction AA plus BB, that will give CC plus DD. I'm just taking an example. And there is a rate law expression. Rate is equal to basically K into A ka power A A ka power X into B ka power Y. This X and Y is experimentally determined. Then order of reaction will be order of reaction means overall order of the reaction n will be equal to the sum of this power x plus y. Is that clear how to calculate order of reaction? You can calculate the order of reaction only if you know the rate law expression. Only if you know the rate law expression. So X is basically order of reaction with respect to A, with respect to WRT, with respect to A. Y is basically order of reaction with respect to B, with respect to B. But when we say X plus Y, that means basically N is overall order of reaction, overall order of reaction, or we can simply call it order of reaction. Is that clear? Are you done with that? Are you done with this, Madina and Aman?
So one
Yes, sir.
Madina, you are also done with this, right?
Sir, I'm writing the last line only.
Okay, okay. So basically, in rate law expression, what you need to do, just add the power, you will get the order of reaction. Are you done with this now? Madhya, let me know, please.
Done, sir.
Okay. Now this order of reaction may be positive, negative, 0, or fraction. Order can be anything: negative, positive, 0, or fraction. Now I'm going to give you a question on this. Calculate. Either it will be asked overall order of the reaction or order of the reaction, that means same. Calculate overall order of reaction which has rate law expression, the rate law expression is given as rate equals to k into a ka power 1 by 2, a raised to the power 1 by 2, and b raised to the power 3 by 2. Please tell me the order of reaction. Any answer? Let me know when you are done with this. Aman, are you done with this?
Yes, sir. The answer is 2. Order of reaction is 2.
Answer is 2. Very good. Madhya,
Yes, sir. I also got the same answer.
yes. So this is it for today. I will continue from here in the next class.